Alright, so we have a white rhino whose heart rate R is the number of beats per minute, and his lifespan is S, which stands for minutes. And those are based on his body mass, which is in terms of kilograms. So they give you two formulas. The first one is for his heart rate. So you take his mass, you raise it to the negative 0.25 power, and then multiply it by 241. They also give you a formula for his lifespan that you can see. So we're doing 6 times 10 to the 6, and then taking that times the zero point 0.2 power of his mass. So what does all this mean for you? Letter A signs we want you to find, letter A says we want you to find R times S of M. So the first thing they want you to do is take your R of M function and multiply it with your S of M function. So here's what that all breaks down to. This is the same thing as 241 times m to the negative 1/4. So I went ahead and kind of changed that format a little bit. We want to multiply that with this stuff. So this is the same thing as 6 times 10 to the 6 times m to the 1/5 power. So this is the exact same thing as this function times this function. So if we go ahead and multiply a little bit, we can do the 241 times the 6. I'm actually going to leave 10 to the 6 alone because it's pretty big, but we can go ahead and consolidate our m's by adding their exponents. So my exponent will now become negative 1 over 20. It does say leave it in exponential form, but it's always a good habit to have positive exponents, just to kind of keep that rhythm going. So I would probably just leave my answer like this. Then letter B says we want to explain what that actually means. So let's consider we have the formula for his heart rate. So this is his heart rate. And we're taking that times his lifespan. And that is all based on whatever his mass is. So we just say, oh, it's all a function of mass. So if he weighs differently, he's going to have different outcomes for each of these. So what that's going to equate to is the number of heartbeats in his lifetime based on his weight. So I want to turn our attention to more composition functions. I'm going to get a little bit more interesting here. So letter A is actually review. This does not say find g times 3, it says find g of 3, meaning what is the output of that function if I use 3 for x? So of course it's going to be 9. Now this is going to look different. This means what is g of f of x? What that means is you need to take the f of x formula and put it into the g formula. So the first thing I would do is swap out f of x for that formula. So 2x is the formula for f. Then you have to take this 2x and plug it into the g formula for x. So that's going to look like the quantity 2x squared. And if you simplify that, you'll get 4x squared. So g of f of x is the same as 4x squared. Now you are going to see some notation that symbolizes what we just did. So it kind of looks like G-O-F, but it's actually pronounced G of f of x. So if you see this format, it's the same thing as this. They want you to plug f of x into the g function. So we're going to go ahead and do it the other way. This time we want to plug the g function into the f formula. So the first thing I would do is change g of x into whatever the g of x formula is, which is x squared. Then we're going to take this x squared and plug it into the f formula. So I'm going to get 2 times x squared as my answer. And it's almost the exact same format, except this time it would say f of g of x. So the f would come first and the g would come second. So sometimes kids will say, what is FOG-X? It's not FOG-X. It's pronounced f of g of x. It's just, again, more notation. So we're going to do some practice problems, right? So you can see this notation being used, f of g of x. So the first thing that might be helpful is if you change it to this notation. Once I write it as f of g of x, then I can kind of begin my plugging in process. So we can go ahead and swap out g of x for its formula, which is x plus 2. And then what we're going to do is take this x plus 2 and we're going to plug it into the f formula. So I'll have a 2, but in x's spot, we'll go x plus 2, and then I'll have minus 5. And then I'm just going to simplify that and get 2x minus 1. So now I'm going to do the g of f of x. So we're going to write g of f of x. We're going to swap out f of x for its formula, which is 2x minus 5. And then we're going to take this right here, and we're going to plug it in for x into the g formula. So I'll have x, which is now 2x minus 5, plus 2, and I'll get 2x minus 3. When I do the next one, I'm going to begin the same way. I'm going to change this to f of g of x, and I'm going to change this one to g of f of x. We're going to plug in the g formula, which is x minus 3. Over here, we're going to plug in the f formula, which is x squared plus 7. So I need to plug x minus 3 into the f formula. So I need to put that in for x right here. So it's going to look like x minus 3 squared plus 7. If I look at this side, I want to put x squared plus 7 into the g formula. So I want to put it in right here. That'll get me x squared plus 7 minus 3. All I have to do now is just simplify each expression. So if I FOIL this out, I will get x squared minus 6x plus 9. And over here, all I can really do is the 7 minus 3. So my answer is x squared minus 4. And over here, I'll have x squared minus 6x plus 16. So that's kind of the idea. We're kind of substituting, and then we're substituting again and simplifying. So we'll do one more video where I'll take you through a couple more problems, and then we'll give you a little challenge problem to finish it up.